In 1975, somewhere over the Pacific Northwest, a flight engineer sat behind two pilots, surrounded by more switches, gauges, and dials than most people will ever see in their lives. And he was working, not watching, working, because the aircraft in front of him didn't just fly, it demanded to be flown. This was the Boeing 727, a plane so mechanically alive that pilots who trained on it still talk about it decades later with something close to reverence. Not because it was easy, because it was the opposite of easy. And that's exactly why they loved it. Today, we're breaking down why the 727 earned the nickname the most fun jet ever built, and how a plane born out of three airlines who couldn't agree on anything became one of the most beloved aircraft in aviation history. Let's rewind. In the early 1960s, Boeing had a hit on its hands with the 707, fast, powerful, and completely useless for most of the world's airports because it needed a runway long enough to feel like a highway. Regional airports simply didn't have that kind of real estate, and Boeing knew it. Every airline that wanted to connect a small city to a major hub was stuck flying propeller aircraft from an earlier era, while the rest of the industry moved on without them. So Boeing went to the airlines to figure out what would work instead, and got three wildly different answers. United wanted four engines, because their high-altitude hub in Denver choked engine performance, and thinner air at altitude meant every extra engine mattered for a safe takeoff. American wanted just two, lean and efficient, arguing that anything more was deadweight and extra maintenance cost. Eastern wanted three, because regulations at the time kept twin-engine jets tethered close to land in case of an engine failure over water, and their routes ran straight through the Caribbean, over long stretches of open ocean. Somehow, Boeing had to build one airplane that satisfied all three demands at once. This wasn't a boardroom disagreement that got smoothed over with a diplomatic memo. Engineers from Boeing were literally sitting across the table from rival airline executives who wanted fundamentally different machines. And in the middle of all that noise, Boeing was also quietly talking to a British manufacturer, de Havilland, who was working on their own three-engine jet. For a moment, it looked like the two companies might team up. Engineers were exchanged. Designs were compared. Then de Havilland asked Boeing to simply license and build their aircraft. And Boeing walked away. They wanted an American airplane built for American runways with 6 seats across the cabin instead of 5. That decision, made in a moment of corporate friction, shaped everything that came after. The result of all this disagreement was a compromise, but it turned out to be one of the most brilliant compromises in aviation history. Picture the requirements Boeing's engineers were handed: short runways, a full passenger load, medium-range flying, and 3 engines. But nobody wanted those engines hanging under the wings, because every inch of wing needed to be free for lift devices. On paper, those requirements almost cancel each other out. You can't easily have a small, nimble jet and a wing loaded with heavy high-lift hardware without somewhere to put the engines that doesn't compromise it. So they got creative. 2 engines were mounted on pylons on the sides of the rear fuselage, angled just enough to keep their exhaust clear of the tail surfaces. The third, the one that made this plane genuinely strange, was buried inside the base of the tail fin itself, fed by a long, curved S-shaped duct that pulled air in from an inlet above the fuselage and bent it downward into the engine's intake. No other airliner of the era attempted anything quite like it. It was elegant on paper, and it caused problems almost immediately. On the very first test flight of the prototype, that curved duct distorted the airflow enough to make the center engine surge right at takeoff, the worst possible moment for something to go wrong. Engineers went back to the drawing board and added large vortex generators inside the first bend of the duct, small fins that forced the air to behave itself before it reached the engine face. Problem solved? But it was an early sign. This aircraft would punish anyone who treated it casually. And because the tail carried all 3 engines, the wings were free to become something special. Boeing loaded the leading edge with Kruger flaps and extendable slats, reaching all the way to the wingtips, and cover the trailing edge with triple-slotted Fowler flaps running the entire span. Together, this system pushed the wing's maximum lift coefficient up to a remarkable 3.0, a number most airliners of that era couldn't dream of. In practical terms, that meant the 727 could land safely on runways as short as 4,800 feet and take off from strips as tight as 4,500 feet. Airports the 707 could never touch were suddenly open for business, and small regional fields that had only ever seen propeller planes were now watching jets taxi up to their terminals. The 727 wasn't just capable, it was independent, in a way that almost no jet since has replicated. It carried its own auxiliary power unit, tucked into an unconventional spot inside the keel beam of the main landing gear bay, so it could run its own electrical systems and air conditioning without a ground crew or a running engine anywhere nearby. Land this thing on a gravel strip in the middle of nowhere, and it could keep the cabin lit and cool while it waited for its next load of passengers or cargo, with nobody else around to help it. It had a fold-down air stair built directly into its belly, letting it open its own door on a runway with no jetway in sight. Passengers could walk straight down a built-in staircase onto the tarmac. It even had a small retractable skid built into the tail, just in case a pilot rotated a little too aggressively on takeoff and dragged the rear fuselage across the runway. Small details like that reveal what kind of airplane this was designed to be. Not a machine built for the pristine, climate-controlled world of a major international hub, but one engineered to survive real-world conditions. Short strips, missing infrastructure, and airports that had never seen a jet before. This was an aircraft engineered to land somewhere remote, shut itself down, take care of its own needs, and be ready to go again. No favors required. Here's where the fun really starts. Step into a modern twin-engine cockpit, and you'll find two pilots. Step into a 727 in its prime, and there were three: captain, first officer, and a flight engineer stationed behind them, facing sideways, working a wall of gauges, switches, and warning lights that most passengers walking past the cockpit door never even knew existed. This wasn't a decorative role, and it wasn't there to fetch coffee. The 727 systems were complex enough that flying it safely meant having someone whose entire job was managing the machine itself. Fuel distribution, hydraulic pressure, electrical loads, pneumatic systems, all monitored in real time by a dedicated crew member with nothing else on his mind. It turned every flight into a genuine team effort. Three people working in constant coordination rather than one pilot flying and one pilot monitoring. And on approach, the plane had a personality all its own. Push those flaps to their maximum 40-degree setting, and the 727 could develop a dangerously high sink rate on final approach, or worse, an outright stall, with very little warning before things went wrong. Airlines reviewed years of accident data and responded by revising their pilot operating handbooks, capping flap use at 30 degrees for normal operations. Some carriers went even further, physically bolting plates into the flap lever slot so pilots couldn't select more than 30 degrees even if they wanted to, removing the temptation entirely. A pilot trained on the 727 learned very quickly that this was not an airplane you flew on autopilot mentally. It rewarded precision, punished shortcuts, and made you feel every single control input in a way that later, more automated aircraft simply wouldn't. Then there's the story that made the 727 famous outside of aviation circles entirely. In November 1971, a man calling himself D.B. Cooper boarded a Northwest Airlines 727, calmly informed a flight attendant he had a bomb, and demanded $200,000 in cash along with parachutes. Once the ransom was delivered, he ordered the crew to fly south at a low altitude with the flaps partially extended, then use that same rear air stair, the one designed to let passengers walk off a plane without a jetway, to lower it mid-flight and step out into the night somewhere over the Pacific Northwest. He was never found. No body, no parachute, almost none of the ransom money ever recovered. It remains the only unsolved commercial aircraft hijacking in American history. If you enjoyed this story, subscribe and let us know in the comments what aircraft you want us to break down next.